So, have you ever really stopped to wonder how psychologists actually know what they know? I mean, how do they get from a simple question about why we do the things we do to a solid scientific conclusion? Well, today we're cracking open the psychologist's playbook. We're going to break down the exact methods they use to explore the human mind. Let's get into it.
Okay, take a question like this one. It's massive, right? And everybody has an opinion. But for a psychologist, an opinion or a gut feeling just isn't going to cut it. To get to the real answer, they need a strategy, a research design that can actually separate the facts from all the noise. So, here's our game plan for today. I want you to think of it like we're climbing a ladder of evidence. We're going to start at the very bottom, just describing reality as it is. Then we'll take a step up to see if we can find any connections. And finally, we'll get all the way to the top where we can actually test for a cause. Ready to start climbing?
All right, step one. This is the bedrock of all psychological science. Because before you can even think about explaining anything, you first have to get a clear picture of what's actually going on. This stage is all about careful observation and description.
Now, here's the official definition. But honestly, there's a much better way to think about it. Imagine researchers at this stage are like detectives who've just arrived at a crime scene. The key phrase here is naturally occur. They can't touch anything, they can't change anything. Their one and only job is to systematically describe exactly what they see.
So, how do they actually document all this stuff? Well, psychologists have three main tools in this descriptive toolbox. We're going to touch on all of them, but let's start with a case study so wild and so famous that it literally changed how we understand the human brain. Let me introduce you to Phineas Gage. Back in 1848, Gage was a railroad foreman who had a horrific accident where a massive iron rod shot straight through his head, destroying a huge chunk of his frontal lobe. And the incredible part is, he survived. This tragic, one-of-a-kind event gave scientists a chance to do an in-depth investigation of a single person, which is the very definition of a case study. See, before the accident, Gage was known as a stand-up, reliable guy. But after, he became impulsive, profane, and just different. And that's where you see both the power and the weakness of a case study. The discovery was huge. It was one of the first pieces of solid evidence linking a specific part of the brain to personality. But, and this is a big but, Gage was just one guy. Can you really apply the lessons from his unique freak accident to everyone else? Probably not. And in science, we have a term for that: low generalizability.
And you see these kinds of trade-offs with the other descriptive tools too. You've got naturalistic observation. Just think of Jane Goodall living with chimps in the wild. You get incredibly real, authentic behavior, but you have absolutely zero control over the situation. And then you have surveys. They're awesome for getting data from tons of people quickly, but their big flaw is that you're just trusting people to answer honestly. Okay, so we've described what's happening. The next logical move is to see if any of these things we're observing are connected. We're climbing up the ladder now, from just asking what's happening to asking, is there a pattern here? And this is exactly where correlational research comes into play. We're hunting for relationships, for associations. So let's go back to our original question. Is there a relationship between the hours you spend on social media and your level of loneliness? A correlational study is designed to look for that exact kind of link. And researchers have this really clever tool to measure these relationships. It's called the correlation coefficient, or just R for short. It's just a single number that ranges from -1 to +1, and it tells you two incredibly important things at a glance. The direction of the relationship, is it positive or negative, and its strength. The closer that number gets to either -1 or +1, the stronger the connection is. Let's quickly break down the two directions. A positive correlation is simple. As one thing goes up, the other thing tends to go up too. Think, the more hours you study, the higher your grades are likely to be. And negative correlation is just the opposite. As one thing goes up, the other tends to go down. For example, the more stress you're under, the fewer hours of sleep you probably get. See? It's pretty straightforward. Now listen up. If you remember only one single thing from this entire explainer, please make it this. This is the absolute golden rule of this kind of research. Just because two things are connected does not mean one causes the other. And here's exactly why. First, you've got what's called the third variable problem. There could be some other hidden factor that's causing both things. You know, ice cream sales and shark attacks are correlated. But does eating ice cream cause shark attacks? Of course not. A third variable, hot weather, causes both. Second, there's the directionality problem. Does heavy social media use cause loneliness, or is it that lonely people are more likely to use social media? a correlation can't tell you which way the arrow points. So, to finally answer that question, to figure out what actually causes what, we have to make our way to the very top of the ladder. This is the point where we stop just watching and we actually start to intervene.
And that brings us to the most powerful tool in the entire psychologist's playbook, the experiment. When a researcher wants to prove, beyond a reasonable doubt, that one thing truly causes another, this is the only way to do it. It is the gold standard for a very good reason.
So, what's the magic behind an experiment? It all comes down to one word: control. The researcher deliberately changes or manipulates one thing, the potential cause, and we call that the independent variable. Then they measure to see if that change had an effect on an outcome, and we call that the dependent variable.
Let's just walk through a quick example. Say we think we have a new study technique that works wonders. First, we manipulate the independent variable. We give one group our new technique and a control group the old one. Now here's the absolute key to the whole thing: random assignment. We put people in those groups completely by chance. Why? Because that makes the two groups basically identical from the start. Finally, we measure our dependent variable, their final exam scores, and we compare the two groups. If our new technique group did better, we can be pretty confident our technique caused it. But of course, not even the gold standard is perfect. There's always a trade-off. Think of it like a seesaw. On one side, you have high internal validity. That controlled lab setting means you're really confident your manipulation caused the result. But on the other side, that perfect, sterile lab isn't much like the messy real world, is it? So you might have low external validity, meaning your findings might not generalize to real life. It's a balancing act every single researcher has to deal with.
All right, we have officially climbed the ladder. We've gone from description to correlation all the way up to causation. So now let's just take a step back and see how all these pieces fit together to build our understanding.
Think of this as your ultimate cheat sheet. It really lays it all out, nice and simple. Descriptive research asks, what's happening? Correlational research asks, are these things related? And only experimental research can truly answer, did one thing cause the other? You can really see how scientific knowledge is built step by step. A researcher might start by describing a behavior, notice a correlation, and then finally design an experiment to nail down the cause.
So, I'm going to leave you with this. The next time you're scrolling and you see a headline that says something like, "New study finds coffee is linked to a longer life," you're now armed to think like a psychologist. What's the very first question that should pop into your head? Was it just a correlation, or did they run a real experiment? Because understanding this playbook doesn't just make you smarter about science, it helps all of us become smarter consumers of information in our everyday lives.